polynomials by polynomials, which means that there is addition and subtraction in both things that we are dividing, the one we are dividing by and the one we are dividing into. There are a couple of ways to do this. One is if the polynomial was factorable, you could factor. In fact, that's what we did in Goal 6.1. Okay? So if the polynomial was factorable, you could factor. But if it's not factorable, that won't work. Okay? So one of the methods is to use long division. Okay? And that's what we're going to learn today. And this is probably the most complicated of them. You also can use something called synthetic division sometimes. And that's what we're going to learn in Goal 6.4. I like synthetic division. I love synthetic division, actually, and what you can do with it. So you'll see that next week. But long division, as much as I honestly hate this, because you're looking at it like, I don't even understand. It's something that you have to know how to do when you do partial fractions in pre-calculus and calculus. Okay, so it's a necessary evil for something later in math. I should just say that. Okay. Other than that, do I really see anything that you would use long division for? No. Honestly, no. Okay? But you got to learn it today. So we're going to do it. So really, long division, like way back when long division. Okay? So we're going to set it up, just like I said. Long division. 3x squared plus 10x minus 9 divided by 3x minus 2. I'm going to be very repetitive here, okay, as I go through these questions. And they're all slightly different than the one I did. So there's difference, going to be little bit differences in each question. Okay, so when you start dividing, kind of like if you were going to take a really large number divided by 692. If you were going to divide something by 692, you would probably round it up to 700 and kind of use that as an estimate. Okay, you wouldn't actually think how many times does 692 go in here. So when we use a polynomial, we kind of use that same concept where we use this part, the 3x, to divide into. So you're going to start by taking 3x divided into 3x squared. When I do these, I word it backwards in my brain because I think it makes more sense to me and works better. So I ask, what would I multiply 3x by to make it 3x squared? And what's that? X. That's what goes up here. So that's what I get when I divide 3x into 3x squared. Now, in long division, what did you do next? You took whatever you had up here, whatever you put up here, and you multiplied it by this thing out here. Well, that's exactly what we do. We're going to be taking, though, a monomial term times a polynomial, so make sure you distribute it to the entire thing. So I'm going to have x times 3x, which is 3x squared, and x times minus 2, which is minus 2x. Notice, because this is important and will be in all my problems here, that my x squareds are lined up and my x's are lined up. That's important. Try to be neat and organized. In long division, what did you do at this point? You subtracted, and that's what we're going to do. Now, people tend to make mistakes when they subtract polynomials when positives and negatives are both involved. If it's all positive numbers, they don't usually make mistakes, but when there's negatives or minuses, we do. So, I'm going to do it slightly different. Subtraction is the same thing as changing the signs and adding. Okay? Subtraction is the same thing as changing the signs and adding. So when I subtract now, I'm going to change my signs, and then I'm going to add. So positive and negative 3 cancel out. That term should always cancel out. If it doesn't cancel, you chose the wrong thing to put up there. And then 10 plus 2 is 12x. And in long division, what did you typically do next? You brought down the next number. Well, that's what you do. You bring down now the minus 9. And we repeat ourselves. 3 will go into 12. If you get a number here that doesn't divide, like if you would have got 7 here or 8 here, and it doesn't go evenly, you did it wrong. Because it's going to go evenly. We're going to work solely with integers. Okay? So, 3x divided into 12x. So remember what I say to myself is, what would I multiply 3x by to get 12x? What would I multiply 3x by to get 12x? 4. Positive or negative? Positive, because that sign's important. So you're going to multiply it by a plus 4. And I'm going to multiply through just like I did with the x. So positive 4 times positive 3x is 12x. Positive 4 times minus 2 is a minus 8. In long division, we would subtract at this point. Subtracting is the same as changing the signs and adding, so that's what I'm going to do. And the reason, again, that I do that, I know you can go 12 minus 12, it cancels, but negative 9 minus the negative 8, people tend to make more mistakes on that than it's worth. So just change the signs, and then we're going to add. So the first term cancels as it always should. If it doesn't, you did something wrong. And then negative 9 plus 8 is a negative 1. That's my remainder. We're not going to write r negative 1. Okay? We're not going to write a big R with a remainder of negative 1. What does it mean I have left? Let's go back to something you did a long time ago. If I took 13 divided by 4, and I got a remainder of 1, what does it mean I actually have left? 1/4. It means you have 1 over that 1/4. Very good. Okay, so your remainder is actually 1/4. So this works the same way. Our remainder is negative 1 over 3x minus 2. And it gets written like that. I always write my remainders with a plus. Even if it's a negative. You could write this as minus 1 over. It will be the same thing. But later down the line, sometimes your remainders can be polynomials over polynomials, and people tend to make mistakes with minuses. So I just always write it plus all the time. This takes some getting used to. If you've never done this before, because they're going to get a little more different as I go through. Any questions so far, though? Okay, let's look at the next one. As I said, each question is going to be slightly different. Okay, so I'm going to set this up in my division. Same process every time. Something's just going to be a little different on this question. Okay, so I'm going to use my x here. I'm going to take x divided into x to the third. Or again, you could ask yourself, what do I multiply x by to get x to the third? And that would be x to the second. Put that up top and I distribute through. So x to the second times x is x to the third. X to the second times negative 3 is a negative 3x to the second. I told you I would be very repetitive, so here it comes again. At this point, you're subtracting. Subtracting is the same thing as changing the signs and adding. So I've changed my signs. My first terms cancel, as they always should. If they don't, you've done something wrong. And then positive 2 and positive 3 give me positive 5. X squared. And I bring down my next term. And this is where it's going to go slightly different. And I go and I repeat. x divided into 5x squared, or what do I multiply x by to get 5x squared? And that's a positive 5x. And I multiply through. 5x times x is 5x squared. 5x times minus 3 is minus 15x. And ding, 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 this is where it's wrong. These terms do not match. One of them has an x and one of them doesn't. So they can't be underneath each other. Leave it, however, in descending order. So I like this. I like my x squared and then my x, but that 27's out of place. So I erase that and I move it down. And in that empty spot, I fill in a 0x as a placeholder. Could you leave it completely blank there? Sure. But the 0x is important to something we're going to do next class, so I'm going to go ahead and put it there. So make sure that your like terms are going underneath each other correctly, okay? So at this point, I am subtracting. So that means I'm going to change my signs and add, so minus, plus. The first terms cancel, as they always should. If they don't, you've done something wrong. 0 and 15 is 15x. Bring down my next term. And repeat the process. X into 15x, or what would I multiply x to get 15x, and that's positive 15. So 15 times x is 15x. 15 times minus 3 is minus 45. At this point in long division, you are subtracting, which is the same thing as changing the signs and adding. So when I add, the first terms cancel, as they always should. If they don't, you've done something wrong. And then I add 27 and 45, and I get 72. A remainder of 72, which is written up on top as 72 over my x minus 3. Okay. Question on that one. Slightly different. Now I'm going to go slightly different again.